Team 7047. Our sponsors are Chrysler, Celanese Engineering, and Kronos. Every person on the team is going to be talking about a different part of the robot or procedure. I'm going to hand it over to Ken, who's going to talk about our community outreach.
Hi. Here's a summary of all of the community outreach we performed this year. We did all of these acts in order just to help promote robotics and make sure that more members could come in next year. Personally, I'm a 7th grader on an 8th grade team, and I'm here to hope to make sure the same amount of people will come in this next year. Alrighty.
Hi, I'm going to be talking about overall design and strategy. Last year we learned that PO analysis is very useful for figuring out the design of your robot. So we took all the different ways you could score points and put it into a PO analysis. We were able to figure out what was the best design, and we found that we really wanted to be able to pick up big balls because they stack way better, score the center goal because that was the most points, and to be able to move around the goals without having them fall over because that would lose us a ton of points. And so then afterwards, we came up with different designs, and then based on those designs, we each made like our own little version of a robot, and then put that into another PO analysis, and we were able to figure out our robot. But sadly, the PO analysis didn't really conclude because we didn't have enough information, and we were divided on either a shooter or a scissor lift, but then we split up into two groups, prototyping, and we figured out that the scissor lift was actually more efficient, and we also both agreed on the fact that the conveyor belt worked very nicely for space, and would pick up balls efficiently. I'm going to hand it off to Nikhil and Chris.
Hi, my name is Nikhil Chopra, and I'll be talking about the belt lift. So our job this year was to help build a belt lift, and our objective was to pick up balls and put them into the bucket. So we ran into many obstacles in the design and build process, and in order to save space in front because we ran out, we had to rotate our lift 90 degrees so it would fit. And so because our job was to get the balls into the bucket, we had to find a way to do that. So we brainstormed different ways to get balls into the bucket, and then we looked at the way other mechanisms worked and looked at that. And one of our flagship ideas was like a golf cart range. It picks up balls as it moves across, and that uses a belt lift and a bucket. So with that in mind, we built this, which is kind of similar, and we have scoops to pick up the balls. And it turned out to be a really good idea to look at the way other mechanisms work because we were able to incorporate functions that they have into our robot. But our only problem is since our scoops were made out of field element balls, we were able to pick up the balls, but they wouldn't fall out because they're the same size. So in order to get this problem over, we tilted the scoops to an angle so they would pick up, and then when they reached the top, they would fall out of the scoop. And I'll introduce Chris.
Hi, I'm Chris Mulville, and I'm going to be talking about the scissor lift. So we decided to use a scissor lift to lift the balls and score them into all 4 different goals because we thought it'd be the most efficient and safe regarding like time and space. But we did run into a few different problems when we were building the scissor. The first thing is the motors didn't have enough room to move along the track and lift the scissor to the full height, and there wasn't enough power to lift the scissor to the full height because the scissor was stressing the motors. So we decided to add rubber bands and bungee cords to reduce the stress, and these bungee cords pre-lifted the scissor before we even activated the motors in order to reduce stress and get the scissor to the full height quicker. Now I'm going to introduce Carlo and Luca.
Hi, my name is Carlo. I'll be talking about our goal latch, which is on the bottom of our robot. So at first, me and Nikhil, we tried to make a design that would actually pick them up. Unfortunately, that didn't work. So we just decided to go for our original design, which would latch onto the goal and then pull it along. Sadly, it would slip off. So after our first competition, we decided to make a new design where we actually made it wider and put foam on the bottom to make it a tighter grip. Then also in the foam, we put some screws, so there was a chance of the screws catching onto the goal and pulling it. Now for Luca.
Hi, my name is Luca Tucci-Barabee, and I'll be talking about chassis and electrical. So first off, we decided to use the same drivetrain as last year because it was effective and it was efficient. We also wanted to make sure we mounted our electrical components as low as possible on the chassis to keep the center of gravity low so our robot wouldn't tip when it was going up the ramp. We then also made some simple bumpers and shields out of plexiglass and metal so it would protect us from aggressive robots and keep balls out of our robot so we wouldn't get any boarding penalties. We then made sure that our top bucket could hold 5 balls, and we made it out of plexiglass so we could make sure that we didn't have more than 5 balls, and to also to see if there's any jams so we could fix them in the game without having to go onto the field. We then made sure that our server door would help guide the balls out and into the cup or into the golden goal, so they would always make it in there. Now I'd like to introduce Raimi and Spencer, who will be talking about programming.
Hi, I'm Raimi, and I'll be talking about tie-up. For tie-up programming, once all our teams decide what controls we're going to need, we start on our tie-up program. For driving controls, driver 1 uses tank mode to control the robot, and we also gave them the bottom servo latch because they would know once they're aligned with the rolling goals to latch out. For driver 2, we wired together the scissors motors onto one joystick and gave them the scoops motor on the other joystick. We also gave them the top servo latch so that because once they knew the scissor was all the way lifted, they could easily release.
I'll be talking about autonomous programming and Creo. First, we realized that we would only have to make one program for both sides because it's the same on both sides. Second, we use LabVIEW because that's what our high school team uses, and it'll be better to know it when we enter our high school years. Third, we realized that when the center goal is rotated to its 3 different positions, it has 3 different distances in centimeters. So it uses an ultrasonic sensor to scan centimeter and run a program. Fourth, we make more than 2 programs so we can prepare for what they can and cannot do. For our ramp program, it uses distance to run down the ramp, lift the small ball into the medium goal, and then moves it to the side. So during teleop, we can put the big ball into the large goal. For our parking zone, it measures one of those 3 distances, and based on it, tries to knock over the kickstand. For Creo, we were able to create half the scissor and half the chassis. And now Alex, the conclusion.
Hello again. I'm going to be talking about our major lessons learned this year. Since last year, we were a rookie team, we didn't get to do much community outreach because we were concentrating on our robot. But this year, we took all the opportunities to do community outreach we could, and it turned out to be really fun. Secondly, gracious professionalism is great. Whenever we need help, another team's there, and whenever another team needs help, we try to be there. Always check your nuts and bolts and wire connections before every run. Fun. You always need fun. We have 2-hour meetings. We always take a 15-minute break to pass a football, play tag, or climb the wood chip piles outside of our robotics lab. It helps get your creative energy moving and also gets your focus back. Finally, we use the PFMEA. We used the PFMEA between last competition and this one to change our robot and all of our strategies. Thank you. That concludes our presentation. Any questions?
Sure. Could you give me an example about specifically how do you do the community outreach?
So when we do stuff like we would go to the areas, like if you look in the book itself, you have the book. Yeah, you can see that we presented our robot at some of the areas where these things were held, like at Ice Cream Social. We just presented our robot at our school, and most people were able to look in and come in and see it.
We presented to the rookie team, No Limits. We also, I helps mentor a FLL team, Henry Falcons, and also we also went to the Girl Scouts and helped and presented there as well.
Also, if you turn to page 54 in our red bound book, you'll find our PFMEA.
Okay. Thank you.
Who helps you? Like, besides mentors, do you have any FRC help or anything like that?
Yes, at our first outreach, we saw, we were talking to some Girl Scouts. We presented to them, showed them the field. And there was an FRC team there. We got to look at their robots. We saw one of their practice competitions. It was really interesting. So they did help us, and they showed us the state of robotics.
And also, the lab that we work in is the FRC. It's our school district's FRC team lab, and they allow us to work in there. So that's a massive help because they have a bunch of tools and a nice area to work.
And last year, an FRC team helped me with programming because we were having a glitch in our autonomous programming, and I'm using their solution still this year.
What was the most fun for you, or the best part?
building the robot and actually getting to see it actually successfully works.
Yeah, that's really satisfying.
Yeah, like last year when the last day before the competition, we made our robot hang. This year, our sister lift worked pretty much flawlessly, even though we had no practice at all. That just really helps.
So I saw you put your brain in the middle of the scissor lift.
Yeah, it's because
What's the rationale behind that?
because our robot's quite boxy. It has a lot of metal on the sides, and it's kind of hard to reach down there. Our coach, Luca, he'll have to reach in before every game, and we thought it's easy to see, and when the scissor's down, it's protected, so he can change it and set the autonomous easily before every match.
When you talked about gracious professionalism, you talked about that a little bit. In your own mind, did other teams help you? You guys helped other teams in other events. Is this your first event? Let me ask you that.
No.
This is our second.
Okay. Did you help other teams in any other events?
Yes,
as well?
we are on facility. All the other teams also work there, but we have different schedules. But sometimes we see them because they need to do extra practice or we need to do extra practice, and we help each other out. Like last year, they had their programming down really well, and we just didn't know how to program it as well. And so one of the things was they helped us the entire practice meeting. We couldn't figure out why the robot wasn't working, and it turned out that a wire wasn't plugged in the right slot, and they figured it out for us. Helped us, and we also helped other teams. Last year, one team couldn't figure out why the robot wasn't working. It turned out it was a bad USB cord.
Also, we use a lot of axle shifts, and last competition, Turbo Turtles, one of their axles got bent, so we gave them one when they needed it.
And the other day, the limits was they were at the van building with us, and they were having some troubles getting their programming to work. So I went over and helped them.
The fab is where we work.
Yeah.
Farm activities for.
One more question.
Yeah, go ahead.
Could you describe how do you work together? Say you meet twice a week, or you subgroup, or whole team?
We
meet 3 times a week.
yeah, Saturdays, and Thursdays and Sundays. We meet at the Fab usually, which is our building.
But one of our mentors has been kind enough to, before the competition, when we made the PFMEA, he was kind enough to let us come to his house and work on that.
And sometimes little special meetings, or after school, we'll just
Have
three people. The drive team will go and practice driving, or I'll just go and work on the autonomous code.
or a chassis team might go and work. So we just have emergency meetings every now and then to help get so we're all on the same page when we meet our meeting.
How did you split up the roles in the team?
Just based on what we want to do.
Also kind of like small groups at times, like
You could do anything you wanted. You kind of can switch.
Yeah, you can switch whenever you wanted. Like I would work on a belt one time, and so sometimes I would work on the scissor lift.
Yeah, it was kind of like where you were needed at the time. If somebody needed help with the chassis, you could say, "Oh, I can help you," and then it wasn't really specific, but I guess we kind of do have our own those.
And
Always the same drivers, always the same coach?
yes.
No.
It's always the same coach, but
Okay.
we have 2 drive teams. So we have our main drive team, which is Spencer and Alex, and then we have our other drive team, which is Ramey and Mitchell, who couldn't make it here today.
Oh,
Yeah, sure.
Okay.
Okay, hey, appreciate it.
Thank you.
Thank you.
I loved your entrance, just like John. I'm a big Muppet fan, so
All right.
thank you. Points right from the back. Thank you.
Good luck with your
Nice job. Thank you.
Thank you.
Good luck today. Have fun.
Guys, we need to move.